Hello everyone, welcome to Neso Academy. In the previous lecture, we have understood the concept of function overloading. We have learned the basics of function overloading in the last lecture. Now we are in this lecture and the name of this lecture is Function Overloading Overload Resolution. In this lecture, we will understand the concept of overload resolution, which is part of the function overloading, and it is quite important for us to understand as well. So without any further delay, let's get started with this lecture and let's see what are the topics. The first topic of this lecture is Introduction to Overload Resolution. First, I will introduce you to the concept of overload resolution. Then we will move to the next topic where we will understand the steps that are adopted by the compiler to resolve overloaded calls. So these are the topics of this lecture. Let's start with the first one, that is Introduction to Overload Resolution. Now, what is overload resolution? In function overloading, it is possible that many functions match with a single function call. We know the concept of function overloading from the last lecture. We learned that we can define functions with same name, but they must differ by parameters. Now, parameters can differ by number, order, or type. So, we can define functions with same name in C++. But the only condition is that the parameters must be different. We also learned that we can call an overloaded function. A specific function call matches with the specific function definition and that function will be called. But there is one more possibility. When we call a function, then it is possible that that function call can match with multiple function definitions. That is what I have mentioned here. In function overloading, it is possible that many functions match with a single function call. If that is the case, then the compiler has to find the best match, because a specific function call can only match with a specific function definition. There can be one match possible, and hence a function call can resolve to a specific function definition. That's the second point. As there can be only one match possible, compiler has to find the best match. The process of matching a function call to a specific overloaded function is called overload resolution. So that's the concept of overload resolution. It is the process of finding the best match for a specific function call. So that's the concept. Now let's understand this concept properly through examples as well. Here is the example of straightforward match. Let's say we have display function with parameter I of type integer. And we have one more function with the same name, but the type of the parameter is double. So we have overloaded functions here. Now let's call the display function with value 2. As we have an integer value here, this function call will be resolved to the first function definition because there is an exact match. You can observe that the type of this argument is matching with the type of this parameter. Clearly, this function call will be resolved to this function definition. Now, what about this function call? Here we are calling the display function with value 2.5. 2.5 is a double value. This will be resolved to this function definition. Here we can observe the type of this parameter is double. So the type of this argument is matching with the type of this parameter, and hence this specific function call will be resolved to this specific definition. I hope this idea is clear to you. Here we have straightforward matches. Compiler has to do less job in these cases. Now, what about a complex match? There is the possibility that a specific function call may match with multiple function definitions. Let's take an example for the same. Now we are taking an example of a complex match. Again, we are considering the same functions, but this time let's call the display function with the character A. Now we can observe there is no exact match. Here we have the type of the argument as character. Here we have the types as integer and double. There is no exact match. But if you observe carefully, this function call is matching with both these functions indirectly. We know that a character can be placed inside an integer variable and it can also be placed inside a double variable without any data loss. So we can say that this specific function call is indirectly matching with these two function definitions. So that's the point. It is possible that many functions match with a single function call. If that's the case, then compiler has to find the best match. Here the compiler has to find the best match for this function call. But the question is, how does the compiler finds the best match? That is how compiler performs the overload resolution. Now, this is exactly what we will understand in the next topic. In the next topic, we will learn the steps which are adopted by the compiler to resolve such function calls and to find the best match. For now, we are done with the introduction. We have understood overload resolution properly. So, this means we are done with the first topic. Now, let's move to the second topic to understand the steps that are adopted by the compiler to resolve overloaded calls. Now here comes the step number 1. The first step that is performed by the compiler is to find the exact match. Compiler checks if the type of the arguments are matching with the type of the parameters. If that's the case, then there will be an exact match, and the compiler will resolve that specific function call to the specific function definition. Now let's take an example to understand this. Here we have these two functions definitions. We have functions with same name but different parameters. Inside the main function, one function is called with value 10. Here we have an integer value. We know the argument type is matching with this specific parameter type. Here we have the parameter of type integer. So clearly, this function call will be resolved to this definition. Now what about this function call? Here we have a double value. Clearly, the type of this argument is matching with the type of this parameter. Here we have an exact match. Therefore, this function call will be resolved to this function definition. So that's the concept of exact matches. I hope this is clear to you. That is the first step compiler takes. If compiler finds that the type of the arguments are matching with the type of the parameters, then the process will be stopped. No further step will be performed by the compiler, and compiler will resolve the function call to the specific function definition. So in this way, compiler finds the best match. But what happens if there is no exact match? If there is no exact match, then compiler will move to the second step where it will perform the type promotion. If no exact match, then compiler tries to promote the type of the argument to match with the parameter. Type promotion refers to conversion of lower type to higher type. And this conversion happens between the same categories of types. Integral type is usually converted to an integral type. Floating point type is usually converted to a floating point type. This is exactly what the type promotion is. Type promotion happens when there is no exact match. Now let's take an example to properly understand this. Here is the example program. We have the same function definitions. Inside the main function, we are calling the fun function with character A. Now we can observe that the type of this argument is not matching with these types. Therefore, there is no exact match. Now compiler tries to perform the type promotion, clearly because there is no exact match. Now how compiler performs the type promotion? We know that we can store a character within an integer variable or a double variable. Here we have a lower type and here we have higher types. Now, which type will this specific type will be converted to? That's the question. Character will be converted to integer type. There are a couple of reasons behind this. Character and integer are belonging to the same category, that is integral types. So these two are integral types. That's the first thing. Here we have a floating point type. We know type promotion happens between the same categories of types. So clearly, this character must be converted to an integer type. Second reason is character is lower type compared to integer. Therefore, it makes sense to convert this type of character to integer. So this function will be resolved to this definition. I hope this idea is clear to you. So here we have type promotion. This character type is promoted to integer type. Now what about this function call? Here we have this float value 3.14f. We have an f over here which indicates that this is a float value. This type does not match with any of these types. But here we can observe that we have the same category type which is double. Also, double is higher type compared to float type. So clearly, type promotion happens here and this function call will be resolved to this definition. I hope this idea is completely clear to you. So that's the concept of type promotion, and it happens only when there is no exact match. Now here are a couple of more examples. A character can be converted to integer. They belong to integral type category. And of course, we can observe that char type is lesser than int type. Similarly, float can be converted to double, bool can be converted to int can be converted to long. Here, I am providing some of these types. For other types, you can find this on your own, how the type will be promoted to other type. I gave you the rules, now you can solve these type of problems. So with this, we have understood type promotion properly. Now, what happens if type promotion cannot be performed? If that is the case, then compiler moves to the third step, which is type conversion. If no match found via type promotion, then type conversion is performed by the compiler. If type promotion cannot be performed, then type conversion happens. Now, what's the difference between type conversion and type promotion? First of all, in case of type conversion, there is the possibility that a specific type can be converted to some other category type. It is possible that an integral type can be converted to a floating point type. If the type promotion is not possible, then type conversion must happen. This means implicit type conversion will be performed by the compiler. There is the possibility of conversion of different categories of types. Also, lower data type can be converted to a higher data type, or there is the possibility that the higher data type can be converted to lower data type. So there can be data loss in case of type conversion. I hope the difference is clear. It will be more clear through an example. Let's take the example. Here I have defined these two functions. The names of these two functions are same. We have fun. And here we can observe the parameters are different. We have the parameter of type double and we have the parameter of type string. Now inside this main function, I am calling the fun function with character A. Here we can observe we do not have an exact match. And type promotion is also not possible. If you are thinking that character can be promoted to double, this is not type promotion. A character cannot be promoted to double because they belong to different categories. And character cannot be implicitly converted to a string. That is also the case. We need to explicitly convert a character to a string. So here, implicit type conversion cannot happen. So this option is eliminated. Now we are left with just this option. Can a character be type converted to double? That's the question. Yes, they belong to different categories, and implicit type conversion can happen. Therefore, this function call will be resolved to this definition. So I hope this is clear to you. What is type conversion? Now here are some examples. Long can be converted to int, although this conversion may lead to data loss. But if this is the possibility, then this may happen. This is type conversion. A character can be converted to double. These two belong to different categories. This is the integral type and this is the floating point type. Similarly, int can be converted to double. They also belong to different categories. I hope this is clear to you. So that's the concept of type conversion. Type conversion happens when there is no exact match and when type promotion is not possible. Now, what if type conversion is also not possible? If that is the case, then compiler will move to step number 4. In step number 4, compiler tries to perform user-defined conversion. If no match found via type conversion, then compiler tries to find a match through user-defined conversion. Now, what happens in this case? Let's try to understand this through an example. Here in this example, you can observe that I have defined a class. You might not know what a class is. I will give you the surface level understanding about classes and this specific class. Later in this course, we will properly understand the concept of classes because we have a dedicated chapter for object-oriented programming. For now, let me tell you what a class is on the surface level. Think of a class as a user-defined type. Here, to the class, you can provide the code you want. Here I have provided this code. This specific code will turn an object of this type to an integer type. That is what is given here. And it will also provide value 1 to the object. Now here I have defined these two functions. They have the same name, types are different. Function overloading is performed. Here you can observe inside this main function, I have defined the object I of type myInt. We know myInt is the class. But what happens behind the scenes is that this myInt will be replaced by int and variable I will receive value 1. Now this function is called. This function has been called with I. Now what happens in this case? Here there is no exact match. We can observe that myInt is not matching with int or double. Apart from this, there is no type promotion because we have a user-defined type here. And there is no type conversion. So clearly here, user-defined conversion will happen because this is a user-defined type. This type is defined by us. Compiler will find that this specific type will be replaced by int. So here we will get int. And here we are passing an integer variable. So the argument is of type integer. Clearly, this function call will be resolved to this definition. I hope this is clear to you. So that's the concept of user-defined conversion. User-defined conversion happens when exact match cannot be found, type promotion is not possible, and type conversion is also not possible. So with this, we have understood the user-defined conversion as well. Now, what happens if user-defined conversion is also not possible? If that is the case, then compiler moves to the 5th step. Step number 5 is ellipsis conversion. Ellipsis matches with any type, but this is used as the last resort. So it is considered as the last resort by the compiler. When no other step can be performed, then ellipsis conversion is what is performed by the compiler. Now let's take an example to understand this. Here in this example, we have defined these functions, and here you can observe that this function has been defined with ellipsis. This ellipsis can match with any type. Inside the main function, I am calling the fun function with value 3. Now here we can observe we have an integer value. We know that ellipses can match with this type. But the point is that ellipses conversion happen at the end as the last resort. Here we already have the function with the parameter of type integer. So clearly this function call will be resolved to this definition because there is an exact match. And we know exact match is the step number 1 performed by the compiler. Compiler always performs these steps in a sequence starting from step number 1 up to step number 5. Step number 5 is the last step. This is the last resort. Now what about this function call? Here we are passing a string hello. Now here we can observe that hello is not matching with int. So there is no exact match. We can observe this. Apart from this, type promotion is not possible. Type conversion is also not possible. There is no user-defined conversion. So we are left with ellipses conversion. Here we have ellipses. Therefore, this function call will be resolved to this definition. I hope this is clear to you. So that's the concept of ellipses conversion. This is performed as the last resort by the compiler. So with this, we have understood all the 5 steps which are performed by the compiler to resolve overloaded calls. In this way, compiler finds the best match. If at all it is the case that ellipses conversion cannot happen, then we may get error from the compiler. So there can be the possibility that a specific function call may not resolve to any function definition. In that case, we may get error. So with this, we have understood all the steps, and this means we are done with the last topic as well. And we are done with all the topics of this lecture. Okay friends, this is it for now. Thank you for watching this lecture. I will see you in the next one.